We've been speaking about the risks. Now let's dive a little bit in more details into the CO2 emissions from a metal. We'll take just one example, which is aluminum. Well, let me first introduce you the ore of aluminum. Aluminum cannot be found on Earth, on the ground, just like this. It doesn't work like that. There is an ore, and let me introduce you bauxite. Bauxite is a rock composed of different oxides. You have, for example, aluminum oxides, Al2O3. You have silicon dioxide, also known as silica, which is similar to the sand. You have iron oxide, which is giving to the bauxite this red color, and you may have some other oxides of titanium oxide. So you have this, in this rock, it looks like just a red rock, but it's actually a very complex thing with many different metal oxides. So first you have a process called the Bayer process that helps you to clean this rock that has to be crushed. So here is the source of energy to be then the pure aluminum oxide, the alumina. And here, let me introduce you alumina, which is white. It's still quite different than your aluminum foil that you have in your kitchen, isn't it? Alumina is actually when an aluminum atom is bonded with oxygen atom. Actually, 2 aluminum atoms are bonded with 3 oxygen atoms. And here comes the problem. Aluminum and oxygen, they love each other, which means that their chemical bond is very strong. It means that it will cost you a lot of energy to separate them. How do we actually do that? Well, basically we have to rise to work at high temperature. Actually, we have to use some chemicals with fluorine to make it liquid at high temperature. And we have to apply a very strong electric current. We are speaking only about a few volts, 4 volts, but we are speaking about hundreds of thousands of kiloamperes. Just for you to know, your house consumes a few amperes, right? And a human being actually dies after 75 milliamperes. This is known to be the lethal dose in electricity. Now we are speaking about thousands, hundreds of thousands of kiloamperes. This is a huge amount of energy. Well, to do this, we also need some carbon, some graphite electrode, and we do electrochemistry. Let me show you now in this slide a simple version of the chemical equation. So you see we have Al2O3, this alumina that comes from the cleaned bauxite, plus the carbon of the electrode. And if we add some current here, we can have pure aluminum, but of course, the oxygen is not staying alone. The oxygen is caught by the carbon. Carbon helps to catch the oxygen atom from the aluminum. It's great, you get the aluminum you want, but there is a price to that. This is the CO2. So now I would like you to calculate how much CO2 is emitted by this process. The answer is approximately 1.2 tons of CO2 per ton of aluminum. Is that a lot? Remember the previous module, I was saying that steel is the cleanest metal by unit of mass with 2 tons of CO2 per ton. Now we're speaking about 1.2. Where does this difference come from? First of all, you may say, well, this is the efficiency of the process. That would be true. The efficiency of a process, no industrial process is efficient at 100%. You have different types of losses. Actually, the efficiency of the aluminum production process is estimated to be 80%, which would give you 1.5. We are still below steel. Another answer you may tell me is that extracting the rock costed energy. Transforming this bauxite into alumina consumed energy. Yes, that's true. We estimate that it's approximately we need 4 tons, it means 4 tons of CO2 to have enough alumina to produce 1 ton of aluminum. 4 plus 1.5, that gives 5.5. Okay, is that what the scientific paper are telling us? Actually, we are still quite far from the results. The consensus data says that it's about from 8 to 12 tons of CO2 per ton of aluminum. Where does this difference come from? It actually comes from the electricity. And here we should be very careful. So you can calculate with this half equation that I show you here. If you have basics in electrochemistry, you can just simply calculate the amount of energy that is needed per tons of CO2. The answer is approximately 12.5 megawatt hour of electricity per tons of CO2. Now you have to understand, how can I go from megawatt hour all the way to CO2? Here we come again to the renewable energy. Yes, nuclear energy will be only a few grams of CO2 per megawatt hour, while coal energy will be about a ton of CO2 per megawatt hour. So you understand that producing your aluminum will require you 12 megawatt hour, and your energy may emit few grams or tens of grams of CO2 or 12 tons. That's the difference. So this is why you may have a very big difference in your CO2 emission of aluminum depending on the energy that you are using. And this varies from country to country. This is why you can have difference on the production, on the CO2 emission, depending on the country where you are. So this example of aluminum is very peculiar because aluminum is one of the metals produced by what we call electrometallurgy. So we directly use the electricity to create the metal. Some other processes can be hydrometallurgy with some chemicals, or pyrometallurgy with some heat. But in all the cases, there will be some energy. The energy can be through transport, through heating, through different processes. Every time there will be a lot of energy involved. And the question is, where does this energy come from and how much CO2 is emitted per unit of energy? This is the key parameter to reduce significantly the emission of CO2 per unit of mass of metal.